Reinforced concrete beams, shearing stirrups, example 1. In this example, we have a concrete block which has three number 9 rebars embedded in it. So if we do know that specific strength of concrete is 3000 pound inches squared for our problem, and also yield stress of steel is 40,000, and we do know that area for number 9 for each of them is 1 inch squared. So this is 1, this is 2, this is a 3 of them. So the area total for steel is 3 inches squared. For below cross section, we want to calculate the minimum amount of shear reinforcement, which is the stirrups. And while we do know that there is a dead shear of 5 kilopounds, live shear of 15 kilopounds, and if needed, center to center stirrup spacing is 8 inches, the distance between the shearing reinforcement. So based off of a ACI code, so share of concrete from shear is 2 times B times D. If this is H 23, and you have to subtract the distance of centroid from the bottom, which is 3 inches, and so that's 23 minus 3 is 20. That's effective depth D, and times the square root of f prime c. If you replace that, that's 2 times 12 times 20, the square root of 3000, and that gives us a 26.29 kilopounds. And at the same time, ultimate shear is a combination of dead load and live load of shear. And if you do so, it just gives us a 30 kilopounds. There is a reduction factor for shear, which is 75.75. And if base of ACI, if VU is larger than phi times VC over 2, stirrups required. So if you do the math for our problem, we calculated the share of concrete from shear is 26.29, ultimate shear is 30 kilopounds, and P times VC is equal to 9.9, almost 10. So definitely 30 is higher than 9.9, so we do need stirrups, and from ACI code, that's the VS, V of stirrups comes from this equation. So required and maximum permitted stirrups based off ACI code are in when VU is smaller than smaller or equal to phi times VC over 2, which is not our case. There is no stirrups needed, and because it was 30 and it was higher than 9.9, so if VU 30 is higher than a 9.9 phi times VC over 2, we do need to follow this formula from ACI code. VS and also a spacing distance. So let's jump to ACI code, American Concrete Institute 22.5.8.1. It says if VU, so far we do know that we do need a shearing reinforcement because a VU is higher than half of phi times VC. So now it just says if you do need that and VU ultimate is also bigger than phi times VC, which is phi times VC is 75.75 times a 26.29, that's 9.72, and VU is already 30. So VU is also bigger than phi times VC, so then we use this equation. So VS is equal to shear of stirrups, it's VU over phi minus VU. If you do so, VS is equal to 13.71 times 10 cubed pounds. And it just says in a next session, it just says VS is also area of stirrups times F, Y of times effective depth over spacing, which is provided in our case 8 inches in problem statement. So if you replace this equation for AV, it just gives you AV equal to this amount, and it just gives us AV almost 0.14 inch squared. Thank you. We'll solve more problem in next videos. Thank you.